Okay, we're going to start the second video here for section 8.1. We had left off talking about how to interpret a confidence interval. We haven't quite looked at how to construct a confidence interval, but let's go ahead where we left off in the last video. This is a really nice review of what we had learned in that video. In this example titled, Who Will Win the Election? It says 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the confidence interval for the population proportion who favor candidate A is, and then you can see we have a confidence interval that's constructed. So this represents the proportion of the population who would be in favor of candidate A. Okay, what we're asked to do here in part A is to interpret the confidence interval. And we had discussed the template on the previous video for how to interpret a confidence interval. That interpretation should begin stating the confidence level, which is we are 95% confident that the interval, and we want to state that interval, between 0.48 and 0.54 captures, and we want to say what in context are we capturing in that interval, captures the true population proportion of voters who support candidate A. You notice that's what I highlighted there in the problem. Okay, part B says what is the point estimate that would have been used to create this interval, and then what is the margin of error? Okay, now remember the point estimate would be the exact middle of your confidence interval. That would have been where your sample proportion would have been located. So if we can simply add together the endpoints of our confidence interval, find the center by dividing by 2, and we get that the sample proportion from the sample that would have been taken here would have been roughly 0.51. Okay, that is the point estimate. Now the other part to part B says what is the margin of error? The margin of error is what is being added and subtracted from your point estimate to then create this window for your confidence interval. Okay, so the margin of error can be found by either taking either endpoint actually of your interval and finding the distance from that to the very center, which is where the point estimate is. So we get that distance to be roughly 0.03. That means our margin of error is 3%. 3% there. Okay, and then part C, it says based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. Okay? So here's what we're looking for when we're evaluating a claim similar to this. Okay? Now keep in mind here that the interval, we'll go ahead and write down what that is so that we can see. Here was the confidence interval. It was 0.48 to 0.54. Okay? So we want to be looking, remember this reporter is saying that the majority of people were in favor of candidate A. I'm seeing that while there are some values that are larger than 50%, there are also some values that are not larger than 50%. And so what we would say is since there are some values that are less than or equal to 50%, those are plausible or believable values in the interval. There is not convincing evidence that the majority of registered voters are in favor of candidate A. Okay? So when they use a phrase like majority, we would need the entire confidence interval to be above the 50% mark. Now, had the confidence interval been, say, from 0.51 to 0.57, we would then say that that is convincing evidence that yes, the majority of registered voters are certainly in favor of candidate A, but since it is plausible that the proportion could be 50% or under, then we're saying that's not convincing evidence that the majority of them are in favor of candidate A. Okay, what we're going to spend a little bit of time here on next is we're going to take a look at the percentage that's associated with your confidence interval. And we call that a confidence level. So when we say things like creating a 95% confidence interval or a 99% confidence interval, what does that mean when we change the percentage? And that percentage, again, is really the confidence level. And so the setup that we're going to be working with here in this particular example, and then I'm going to switch to an applet that we can kind of see this demonstrated on, is we're going to assume that we're going to be drawing out multiple samples, and we're going to say that the sample size is going to be 16. Okay? Now, when we pull out a sample of size 16, we are going to calculate the mean of that sample. That would be whatever our X bar is, okay? And then we would add and subtract our margin of error. Now at this point, we haven't discussed exactly how to calculate what the margin of error is, but I'm just gonna give you right now that the margin of error would be adding and subtracting 10 from your sample mean. We will be learning here later how to specifically calculate what the margin of error is. But when we add and subtract that, that then creates this window here. Now, what we're going to be focusing on is we're going to be focusing on every time we draw out a sample, if we know that we could get a slightly different mean from our sample because samples vary from one to the next. We're just collecting these randomly here. Okay? When we say that we're creating a 95% confidence interval, though, what we're really saying is if we were to draw out multiple samples, now they have to be the same size, and in this example, we're saying our sample size is 16. If we were to repeatedly draw out samples of size 16 and construct confidence intervals for those samples, we would expect about 95% of those confidence intervals to capture the true location of where the population mean is. You can see this demonstrated in the graphic, and then I'm going to switch to the applet here. What we're looking at is they are showing us, this is supposed to be the population here, or I'm sorry, this is the sampling distribution rather, for X bar. And we know that the center of our sampling distribution should be exactly where the population mean is. We learned that's an unbiased estimator. Okay, what you see underneath with all of these little green segments and these red dots, the red dot represents that we would have drawn out a sample from the population of size 16 and calculate the sample mean, X bar. And the sample mean would be located exactly where you see the red dot. Okay, so this first segment here is going to represent one sample of size 16 that say we drew out. Okay, this is just one sample of size 16. And this red dot right there would be the mean of that sample. Now we had commented that the margin of error on this was adding and subtracting 10. So if I were to stretch 10 to the right and 10 to the left, you can see that creates the green segment that you're seeing here in this picture, which is then my confidence interval. Now the black segment that's running down the middle, you'll notice that's right in line vertically with where we're saying the center of the sampling distribution is, which is where the true location of the population mean is, mu. Okay? And so what we're after is, we're after looking at each of these segments. These are all different samples of size 16, and for each one, we've constructed a 95% confidence interval. And we want to see how many of these samples actually were located directly on where we're saying the population mean is, which is what I just highlighted there in that vertical piece. You'll notice there's this one blue segment off to the right that kind of missed capturing where that true population mean is. But we notice that the majority of them, actually, the interval is capturing that location. Okay, and so when we talk about the confidence level, 95%, what we're really talking about is what is the overall capture rate or the percent hit. So we would expect if we were to take multiple samples and construct multiple 95% confidence intervals, we would expect that 95% of those intervals would capture where the true population mean would be located. So I'm just going to switch over to the applet real quickly here. I'm going to go ahead and reset this. Okay, I'm resetting this. You'll notice here we're going to be talking about, I'm going to do this with proportions. Okay, I'm going to take a sample size of 16, and I'm going to take 25 different samples of size 16. I've got my confidence level set at 95%, so I'm going to go ahead and draw out 25 samples from a population whose true proportion is 0.5. That's what I know this looks like it's a pi symbol, but that's what represents the P, the true proportion of the population. What I want you to look at here is I want you to notice how all the confidence intervals that were constructed have captured and included the true population proportion, except this one right here, it missed it. So I think I constructed 25 of them. So 24 out of 25 captured the true population proportion. So that's 96% of the intervals I created. Okay, let me go ahead and try this again here. Okay, and this will just keep a running tally here. Okay, that time 25 of the 25 actually captured where the true population proportion was. So that was 100% of those. If we average that with what we did before, now we're landing at like a 98% capture rate. Okay? And so it's not exact, but when we say the confidence level is 95%, we're saying that we're expecting close to 95% of our confidence intervals to capture that true population parameter. Now you notice this last one that I just did, it only had an 84% capture rate, but when we talk about our confidence level, we would want to be referring to taking many, many samples. Again, they all have to be of the same size. These are all sample size 16. You'll notice my running total, though, is a 95% capture rate. Okay, so that's what we mean when we are talking about interpreting a confidence level. Okay? Interpreting a confidence level is different than interpreting a confidence interval. Okay? So I'm going to go ahead and just draw your attention here to a difference when you're interpreting this. When you're saying that you're 95% confident, you're basically saying, if we were to take many samples, and this is the part that's really important, you have to say of the same size from your population, about 95% of them should result in an interval that would capture the, and then right in here, you should fill in the context of what it is we're talking about. Okay, whether it's the true population proportion of something or the true population mean of something. But again, your confidence level is essentially your overall capture rate. Okay? Notice that we are not mentioning in our interpretation for a confidence level, we do not mention the actual interval itself. Okay? We're just stating that if we were to do this repeatedly of the same sample size, that we're expecting that percent of the intervals to capture the actual parameter. Okay. All right, now underneath that, and this was earlier in the notes as well, here is what we had discussed before about how to interpret a confidence interval. Okay, and this is when we actually do state our interval. We are whatever, 95% confident, 99% confident that the interval from blank to blank captures the, and then again, we include the context of what it is that we're referring to. Okay, so let's go ahead and take a look at example 6 here. Okay, underneath, it says, how much does the fat content of brand X hot dogs vary? Well, to find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation sigma is given from 2.84 to 7.55. Now, most of the time in statistics, at least in AP statistics, when we are talking about trying to estimate parameters, it is typically a population proportion or a population mean. But in this example, they're having us estimate the population spread, which is the population standard deviation. So they're asking us to interpret, now notice there is a difference between interpreting a confidence interval and then part two here, which is to interpret the confidence level. Okay? The interval is when we actually state the interval itself. When we start out and say we are 95% confident that the interval from 2.84 to 7.55 captures the true population standard deviation of fat content for brand X hot dogs. Okay, once again, just notice that I included in context what it was that we were talking about in this problem. Okay, that's what those numbers 2.84 to 7.55 are representing. Okay, the true fat content for brand X hot dogs. Now here's the difference between that interpretation and interpreting a confidence level. Okay, recall here that this confidence level was 95%. So we're going to say if we were to take many, many samples of our sample size here for these hot dogs that mentioned up in the problem was a sample size of 10. If we were to take many, many samples of size 10 from this population, about 95% of them will result in an interval that captures the true population standard deviation of fat content for brand X hot dogs. Again, just noting that I did not work into that interpretation at all, the actual interval. I'm just stating my confidence in the capture rate, what we're dealing with here. Okay, and number 3, true or false? The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Justify your answer. You know, we have discussed that the true parameter is not going to jump from one value to another. Okay? So whatever the true population standard deviation is, it is fixed. So to assign a probability to it, that is not what 95% means in this case. We're going to say that's false. Once you have your interval calculated, then either your population standard deviation is contained in that interval 100% of the time, or it's not contained in it. That is, once you have constructed a confidence interval. Okay, you have one and you're looking at it, it's either going to be in it or it's not going to be in it. Okay, so that is a false statement there. Okay, I just want to provide a little bit of clarity here on this next slide in terms of how to go about saying whether you're confident that a single value is in a confidence interval versus a range of values. Okay, so here in this example, it says, is it plausible that there is no difference? And I don't know that this is in your notes or not here, but we're just going to spend a minute here on this. It says, is it plausible that there is no difference in the mean number of texts sent by girls versus boys for the interval from -2.5 to 7.9? Okay, when you see the phrase no difference, that means we're looking for, does this interval contain 0 in it? So that's what you want to ask yourself. Is 0 included somewhere in this interval? Because if 0 is a plausible value, then that is some evidence here that we could say that there could be no difference between the mean number of texts sent by girls versus boys. So if we're just looking for a no difference between two things, you're just looking for that single value. Is 0 included in it, or is it not a plausible value? The difference between that and this question is, and this is where we're talking about like maybe a reporter is claiming that the majority of voters are in favor of, say, candidate A, and there they give us a confidence interval. Now we're not just looking for one specific value like 0 being included. When we're asked whether the majority, we want to look at our interval and ask, is the entire interval in agreement with our confidence interval here, okay, that was constructed? So in other words, is our confidence interval including all proportions that are larger than 50%? And in this case, it's not. The entire interval does not include all of the values above 50%. So there's not strong enough evidence there that the majority of the voters are in fact in favor of candidate A. Okay. Now, if the question was, is it plausible that 52% of the voters are in favor of candidate A? Well, now I'm not asking for an interval. I'm just asking for a single value. And so I would look at the interval and say, since 52% is a plausible value in that interval, then yes, it's definitely plausible that 52% of the voters could be in favor of candidate A. There's a difference there between when they use the word majority and when they're just asking for a single value. Okay, on the next page here, I'm just going to go ahead and uncover this answer here. This is just extra practice with interpreting a confidence interval and interpreting a confidence level. Okay, two different interpretations. You could pause this video and copy down that information so that you have it there in the notes, but it's just another extra problem there to practice interpreting confidence intervals versus confidence levels. And what we're going to just spend this last little bit of time on here is kind of exploring how when we make adjustments to our sample size or the confidence level, like maybe switching from 95% to 99%, how that affects the interval that we are constructing. Okay? So what I'm going to do is I'm going to go ahead and go back and launch that applet that I had open before. And I'm going to set it up with these settings. I'm going to start with a confidence interval that's 95%. I'm going to be taking samples of size 20, and I'm going to take 25 samples. Okay, and we'll get to see those 25 confidence intervals constructed. And then here's the changes that I'm going to make. I'm going to leave my sample size of 20 the same. I'm still going to take 25 samples, but I'm going to switch out my confidence level from 95% to 99%. And then I'm going to go down to 90 and down to 80. And what I want you to look at as I'm switching that is I want you to pay attention to what you think is happening to the length of these confidence intervals. Okay, what's happening to the length of these confidence intervals here? All right, so here we have this set up. I've got sample size of 20. I'm taking 25 samples, and I've got this set at a 95% confidence interval. Okay, so here we can see the length of these green segments. Of course, the red ones are the ones that missed capturing the true population, in this case, proportion I have this set up as. Okay, those are 95% confidence intervals. I'm going to swap this out now for 99% confidence intervals. So I'm going to reset this. You just take a look at the length of those segments there. Okay, we're going to switch this out. I'm going to leave all the rest the same. Okay, now I don't know if you can tell what happened there with those green segments, switching from 95% to 99. It does kind of feel like they got a little longer, like the interval grew, got slightly bigger. Let's go ahead and switch it down to a 90%. Okay, now that is definitely smaller than the 99%. Let's drop it down to 80%. Okay, and that is even smaller yet. Okay, certainly smaller yet. So it's kind of feeling like as your confidence level goes down, it feels like that causes your confidence interval to go down. Okay. Now, one other thing that we'll take a look at, and we'll kind of put this all together here in this chart at the bottom. I'm going to go back, I'm going to reset this so that the confidence level is going to be reset back to 95%. And now we want to see what happens to, once again, the length of your confidence interval as you gradually increase the sample size, okay? as you gradually increase your sample size. Okay, again, we're looking at the length, what's happening to the length of the confidence interval. Okay, so I'm going to reset this. We'll go back to 95%. Okay, I'm going to start with my sample size is just 20. Okay, so there was sample size 20. Now I'm going to reset and increase my sample size to 50. Okay, so now this would be sampling 50 observations. Okay, it felt like those segments got smaller. Let me try a sample size of 100. Okay, the segments again are feeling like it, but notice it's not changing my capture rate. I'm still at least capturing 95% or greater. Okay, let me go ahead and try some more here. Okay, there's some that are missing. Okay, I'm building my way back up to getting close to 95%. So it definitely feels like as I increase my sample size, the interval itself is tending to shrink. Okay, so let's see if we can fill in some of these conclusions here in this chart. This row in this chart is titled Increasing Your Sample Size. So as we increase our sample size, we want to say, you can go ahead and fill in, but that does not affect your confidence level. Okay? You have that, I had that locked in and set that at 95% there. Okay? But we do know this, as we made our sample size get bigger, it did cause the confidence interval, like the length of those segments were decreasing. And so it decreases the confidence interval. Okay, how does that affect the margin of error? Well, remember our formula is to take our point estimate, like either our sample mean or our sample proportion, and we're always adding and subtracting a margin of error to give us that confidence interval. Well, if my confidence interval is going down as my sample size is going up, that's probably also causing my margin of error to go down. Think about it like this. If my point estimate is, say, my average, say, is 7, okay? If I add and subtract 20 versus if I add and subtract 5, the bigger this number is that I'm adding and subtracting, the bigger my interval is going to be. So if I'm talking about my interval decreasing as my sample size is going up, then that probably also means that my margin of error is smaller, decreasing as well. Okay. All right, the next row is titled, as I increase the confidence level. Okay, as I increase the confidence level, what does that do? My middle column here is, how does that affect the interval? Okay, this is when, like we were playing with, going from 99 to 90 to 80. Okay, if we go up to higher and higher confidence intervals, that is actually going to cause your confidence interval to increase, or I could say it's going to cause it to widen. Okay. Remember those segments were getting smaller as my confidence level was going down. So as I increase the confidence level, that means these are going to widen. Also, how would it affect your margin of error? Well, it's probably going to cause that to also increase as well if your interval is increasing. Those tend to do the same thing. Your interval getting wider, well, then your margin of error must have been bigger. And finally, as the margin of error gets smaller, your confidence level would be decreasing, okay, decreases, and your confidence interval would also decrease as your margin of error gets smaller. Okay. So on the next page, here we have kind of a template for how to calculate a confidence interval. Okay, and this is actually on the formula sheet. Okay, it's on the formula sheet here. This is where we had said the point estimate was before. Now for us, our point estimates are typically either going to be a sample proportion or a sample mean. Okay, and then what makes up your margin of error are these two pieces here multiplied together. Something called the critical value, which we will be talking through here. That's going to be a z-score of some sort. and the standard deviation of your statistic, okay, which is either going to be the standard deviation of your sampling distribution for proportions, or it'll be the standard deviation for the sampling distribution for means. So we have our two general formulas here, and I want you to see how these kind of piece together here. If you look at the top, and I'm going to lose this when I scroll, the statistic is either p hat or x bar. So you can see that that's what I have filled in right here. If we're creating a confidence interval for proportions versus sample means, that's going to be your statistic. Okay, then the margin of error are these two things multiplied together. A z-score, and then this is the standard deviation of your statistic. And that is on the formula sheet there. Okay? And this is what it would be for means. Okay, so those just get multiplied together essentially. Okay, so to wrap this up, at the bottom, so how do we find these z-scores then? What is the z-score value for an 80% confidence interval? Okay, well, we could look in the table. Essentially, here's what we're doing when we're trying to find an 80% confidence interval, is we're looking for, what would be the z-score that would act as the barrier to the very middle of our normal curve, holding 80% of the area. Okay, so if that's 80% there in the middle, then that means we're going to have 10% in this tail, and we would have 10% in that tail. Okay, so the way the inverse norm works, we learned this in chapter 2, is we would fill in the area to the left. In the area to the left, I would fill that in as being 10%, because I would be looking for what is this z-score right here. Okay, I would use 0 as my mean, because that's always the mean of a set of z-scores, and 1 as the standard deviation. We could type that into the calculator, and we would get negative 1.28, which means over here this would be positive 1.28. Okay? The other option would be to go to our z-score table and simply look up where the area is 10% in the middle and work our way out, and we would stumble as well on that z-score of 1.28. Okay, so practicing getting some of these z-scores here. Okay, I filled in a few of these for you, but let's look at the 95%. Okay, keep in mind again, a z-score for 95% confidence interval. We want to try to find what are the z-scores where the middle 95% of the area is right there symmetrically in the center. Okay, that means that there's an extra 5%. So half of that, let's do this. Half the 5% is in that tail, and half the 5% is in that tail. So if I want this z-score right here, I'm going to do inverse norm, and I'm going to take that 5% cut in half, and that would be the area to the left. I'm going to type that into the calculator, and that will give me the z-score to be 1.96. 1.96, which is actually the most common confidence interval. Okay, the 99%, it would have been found by essentially doing the same thing. That extra 1%, but it's split between the two tails, you would type that into the calculator. Okay. All right, so just a couple last things here to kind of highlight. We want to make sure that we are familiar with the fact that as the margin of error shrinks, that also causes your confidence level to shrink, but it shrinks and that as a result of your sample size increasing. Okay, so when you take larger and larger samples, that causes your confidence interval to get smaller. Okay, it's like centering in closer and closer and closer around where that true parameter would be located. Okay, on this page, this is just a summary of the conditions for confidence intervals. We know that we have to check off that the data came randomly from a random sample. Okay, here are our conditions for normality. Proportions, if it's a proportion problem, we have to do the large counts condition. If it's a problem about means, we either need to be told that the population distribution was normal, or we can cite the central limit theorem if our sample size is greater than or equal to 30. And finally, the independence condition would be something that would be met if we were able to show the 10% condition. Okay, I'm going to highlight two things on this last page here. Okay, on the last page, I'm going to highlight here this notion that as we increase the sample size, okay, as we increase the sample size, this is something we want to make sure that we memorize here, that impacts the margin of error by causing that to decrease. And finally, there is definitely a trade-off between your confidence level and your margin of error. Okay, if you want to be more confident and go up to a 99% confidence level, what that's going to do is that is going to cause your margin of error to actually go up, okay? Because it's going to cause this to be a bigger number, okay? This is going to be a bigger number that you're adding and subtracting, which is going to widen your confidence interval. And we kind of like confidence intervals to be smaller, because that way they're centered closer and it's narrowing down where that parameter is. When you go wider, it really makes your margin of error bigger. Okay? So actually, smaller confidence intervals are kind of honed in closer around where the parameter is. Okay, that brings this video to a close.